I want to build a circuit to dim a strip of LED lights all the way down to nothing and then all the way back up to full power using pulse width modulation. I followed some tutorials and it took quite a bit of trial and error to get it to work how I want. I learned a few things along the way, so I'm making this video to share some of that. To power an LED from a DC power supply, you usually put a suitable resistor in series to limit the current. Otherwise you can burn out the LED. These strips handle that for you. They have little sections of 3 LEDs and suitable resistors for those LEDs. So we can connect it straight to 12 volts without the need of any other extra resistors. So they're pulling 1 amp at 12 volts, which means they're pulling 12 watts of power. In the last video I built a PWM circuit using a 555 timer. You might want to go back and watch that video if you haven't already. I used that circuit to drive a single LED off of pin 3, the PWM pin of the 555 timer. That works fine for a small load up to about 200 milliamps, but for a bigger load like this strip that can pull 1 amp, we need something that can handle much more power. This is a MOSFET. A MOSFET is a type of transistor. It works really well as a switch, and it can handle much more current than the 555 timer. You can put loads of amps through it without damaging it. When you apply a voltage to the gate pin, it opens a connection between the drain and source pins. Usually a MOSFET is connected at the low side of the thing you want to power, like this. So let's hook this up. The positive rail goes through the LED lights. The negative connects to the middle pin, and then that will open a connection to the source pin, which is connected to ground, and then the gate pin, which is this furthest left pin, gets turned on by pin 3 of the 555, which goes through this resistor, so that gives that a voltage, and when that's not giving it a voltage, rather than floating, the voltage will be pulled down to ground, so it will be 0 volts. Okay, let's connect it and see what happens. Okay, the LED's light. It's a good start. Oh, look at that. That's weird. At the lowest setting, there's a strange little jump, which isn't particularly nice. It's not really what you want your LEDs doing. And I don't feel like this lowest setting is really low enough. Let's see. Without the light on. Yeah, see, that doesn't feel like it's all the way dimmed. So this is the classic approach that lots of tutorials tell you to do to dim LEDs. But I'm having 2 main problems with it. Firstly, it doesn't go dim enough. And secondly, when I turn the knob all the way down, there's a weird flicker. Okay, we're back in the simulator now, and if this looks confusing, then you need to go back and watch the first video where I built this from scratch. The things I've added here is the MOSFET, and I built this kind of array of LED lights to simulate what our actual load is. This here is a 1 mega ohm resistor. You don't need to worry about this. This is essentially not involved in the circuit. I just used it so that I could put a scope on something. So I'm monitoring the voltage across this, which is essentially the same voltage that the LEDs are getting. So we can see on the scopes that the triangle wave is the voltage at this timing capacitor, and the square wave is the voltage that the LEDs are getting. Turning the potentiometer left and right, we can see the change in the triangle wave which leads to the change in the square wave. So to get these lights to go dimmer, we need the on phase to be as short as possible. And from the triangle, we can see that it's about the charging resistance versus the discharging resistance. Like, it's the ratio of those two things. So the first thing I thought about doing here was to disconnect this and to put an extra resistor in here. So let's try that. Let's put a 10k resistor in there. Okay, and you see that really lengthens out the discharging phase. So the blip is actually smaller. And then the other thing I thought about doing is to get rid of the blip when we're at the actual smallest setting. We could add a small resistor in here, which means that we never actually get to 0 ohms along this bit of the circuit. So I tried that as well. I tried a small resistor in here, and I think it did improve things somewhat. But whatever I do, I can't get this blip to be particularly short. And I think the reason that is because of this resistor here. Even when it's over here, like, all the charging has to go through this 1k resistor. So then I thought about switching out, making this 1k resistor smaller. So for example, watch what happens if I make it 500 ohms. See, that goes quite a bit smaller. See, that's smaller than that. If I make it 100 ohms, watch the width of the pulse there. See, it does become a smaller pulse. But the downside of that, and you'll notice it from the speed that the current's flying through there, is when I tried that on the circuit board, this resistor got really hot. So I don't actually want that. I don't want to be making any fire risks or blowing up the circuit. So there's all a bit of whack-a-mole going on. The other thing, of course, is now that I've added in these sort of biasing resistors, is that we've added more resistance to the whole charging and discharging cycle, which means that now the cycle is much longer. Each cycle is much longer, so the frequency has gone down. And if the frequency gets too low, then it starts to flicker, especially if filmed on camera with a high frame rate. So that's not what I want. I want something that I can film even high frame rate and I don't see any flicker. That itself isn't too hard to fix. We can just make this a smaller value, and then that charges and discharges much quicker. So those are the tweaks I did, and maybe I'm missing something. Maybe there's someone who knows how to get this working a lot better, but these made an okay, well, this I couldn't have like that. I had to keep this at 1k for it to be reasonable and not get too hot. And so, yeah, bit of a challenge. I couldn't actually manage to get this to be a good dimmer. So I went to sleep on it, feeling slightly underwhelmed at this result. The next day, I did more research and watched a few more videos, including a teardown of a commercial dimmer switch. And I found a nice simple way to do it, and it uses another IC. And it just so happens to be an IC that I've got in this cheapo wicked kit off eBay. This is a comparator. The job of this IC is to compare two voltages, and it has an output that goes high or low based on which voltage is higher. So to use this, we're going to strip out a load of the bits of this circuit and just use the triangle wave produced by the 555 timer. Ground to there, connect the scope. to that bottom leg there. Yeah, okay, so that's back to just doing the simple triangle. Now I'm connecting up the comparator and connecting its power pins. We want the triangle wave from this, we want this going into input 1, which is that pin there. And then we want the second pin to be connected to a voltage that we can control. So for that, all we need is a simple voltage divider. Okay, that's going to connect to the middle pin there. Now we know the voltage on that pin is swinging from 4 volts to 8 volts. So because this is a 10k potentiometer, if we put a 10k resistor on either side of it, then we should be able to control the voltage in a similar range from 4 volts to 8 volts. So let's go from there to the positive rail with a 10k, and we'll go from here to the 0 volt rail, and then that plonks straight on there. Now let's do a couple of tests. To start with, let's test if this pin is giving us the divided voltage that we want. So if I put that on ground, and if I put that on there, and then if we look at an oscilloscope, now let's put another scope, we'll connect to that same ground, and then we want this on this pin here. Okay, so these are the two signals that we're comparing. There's the triangle that's coming out of the 555 timer, and then we can sweep this down, well, not quite all the way. Would be nice to be able to sweep all the way past the bottom there. In order to do that, I guess I need less than a 10k resistor. Let's try this for now anyway. Let's look at the output of the comparator, which is basically this pin 1. So I think I can just move this over. If I just move that over 1 pin. No, that doesn't appear to be working at all. What's up with that? Okay, I know what it is. The way this works is that the first pin, all it does is it pulls down to ground. When it's not pulling down to ground, it just floats. So in order to get a signal that goes high and low, we need a pull-up resistor. So we need a resistor to pull it up to the high rail, to the positive rail, when it's in its floating state. So we'll use a 4.7k resistor for that, and we'll just connect that to the top rail there. Okay, now hopefully when we connect the power again, okay, we can see that appears to work much better as a signal. basically as the, if I had a 3-channel scope you'd be able to see it better, as the reference voltage that's coming from this voltage divider is coming down, when it's there it's just breaking the tips of the triangle wave, and then it gets bigger and bigger as it's just coming down, and every time the triangle wave breaks out of the top of it, then the output that we're seeing in orange goes high. So I think this is probably good enough for what we want. The nice thing is it's going completely off, which I suspect is going to mean that it will properly dim. Okay, so what we have to do now is we want the output of this. Let's take these scopes off for a minute so we can see what we're doing. We want the output from this comparator to go to the gate of the MOSFET. And I could cut a bit of wire for that, but I'm just going to use a jumper cable because I've got one right here. So we want to go to there, to that first pin. And in theory that's going to drive our LEDs. Let's see. So that's full brightness. Let's turn the light off for the... Had a bit of drama. So yes, they can go very dim. And off. So that's a much nicer curve there of the actual dimmer. So I'm happy with that. My next steps are to build this onto a bit of project board and then install the LEDs on a shelf on my desk. So if you've made it this far in the video, thank you for watching. Please like and subscribe, and I'll catch you in the next one. Peace out.